Right, today we're going to be looking at stoichiometric calculations. This will be the first version that I'll be doing with you. Right, this one does use a mole ratio that we are going to be using. Right, now stoichiometric calculation is not that difficult to understand. Pretty much all we're dealing with is a ratio and our moles. Now, there are some steps that I'll be looking at. These are the steps that I feel are the easiest way to do it. The first one is balancing your equation. You need to balance your equation so that we can create our ratio. Our ratio will be determined via the coefficients of each of the molecules. Then we are going to create a ratio from our balanced equation. Right. Then after that, we are going to calculate the molar mass from our balanced equation. Then we are going to convert all of that into moles. Now, converting into moles, that is going to be also a very important part of the section over here. And then we're going to work out the moles of the unknown substance that we are trying to solve. So with this over here, we are always trying to solve for something. Just like an algebraic equation, we are trying to solve for something that we don't have. And we are using what they have given us to try and solve for it. And then work out the mass that we don't know. So I'm going to be using this over here with you. Right, so let's do this quickly. Right, so I've now given you a question. What mass of nitrogen will combine to form 98 grams of ammonia? Now, step one is to balance the equation, but we also need to create an equation over here. So I know that I'm dealing with nitrogen as well as hydrogen to form this over here. So nitrogen, the atomic molecule, so it's going to be N2 plus H2 is going to give me, what is ammonia? NH3 over here. Now I need to balance this first. Right? Balancing, don't forget, is step one. Step one, I need to balance this here. I've got one nitrogen, so let's make it 2 over here. So I'm going to have 2 nitrogen, that's sorted. But 2 times 3 is going to give me 6. So I've got 6 hydrogen in total. So I need to fix this one over here. So there you go. 6 hydrogen, 2 nitrogen, and therefore it is balanced. So this over here is going to be my balanced equation. From my balanced equation, I am going to create a ratio. My ratio here is 1 is to 3 creates 2, which means if I have 1 mole of N2, I will create 2 ammonia. If I have 3 moles of H2, I will create 2 ammonia. Or I need 1 nitrogen to be consumed with 3 of these to create that. Or if I ask you, how many ammonias will I need? How many ammonias over here will be created if I have 2? How many nitrogens will be created if I have 2 ammonia? 1 nitrogen will be created. Okay, so now that I have that, so my ratio, after my ratio, I need to calculate my molar mass. Now, they have asked me over here what mass of nitrogen, and nitrogen is 1, will combine to form with hydrogen to form ammonia. So my actual ratio that I'm dealing with is 1 is to 2, because they're asking us for nitrogen, what mass of nitrogen. They're just telling us right now it will combine with hydrogen to form ammonia, but they're asking us how much nitrogen will form to create this over here. So now I need to know how much of this I'm going to have. Right, so I've got that over there. Let me do this, step 1 and step 2. Step 3, my molar mass. I'm going to calculate my molar mass of ammonia. Right, so it's going to be my M over here of NH3. Now my NH3, I'm going to calculate. Nitrogen is what on the periodic table? It is 14. And hydrogen, 3 of them, is going to be 3 times 1, which is going to give me over here 17 G mole. Right. That means one of these have this, right? Just one of them. That's it. That's all I'm looking for. My molar mass for this. That is step 3. Now I'm going to convert to moles. So don't worry about your ratio yet. We're still looking at my NH3. Now, they have given me 98 grams of that. So let's convert to moles. Step 4 over here. I'm going to say N is equal to mass over molar mass over there. They've given me 98. So it's going to be 98 over 17, which is going to give me over here 5.76 moles. That is the total amount of moles right now. That's here very important. Right now, this is just in terms of moles, how much I have in terms of one of them over here. But now I need to consider my ratio, which is very, very important. So let's look at my ratio over here. I've got my 5.76 over here, but in terms of nitrogen, my ratio is 2. So this 2 over here, we still need to divide by 2. So I'm going to say 5.76 divided by 2, which is going to give me 2.88 moles. That is how much in terms of moles I have for my ammonia. But they're still asking me for the amounts of nitrogen. So what do I need to do? I need to now calculate the amounts of nitrogen. So with this 2.288, because remember, 2 of these create 1 of these over here. So I'm going to now say 2.88 times 28. Now, where did this 28 come from? It was my mass over here of N2. My N2 over here, don't forget, it's going to be 2 times my 14. My 2 times my 14 is going to give me 20 gmol. Right, so 2.88 times my 28 is going to give me an answer of 80.64. Right? So this is going to be step 5, and then this is going to be step 6 grams. This over here is what? The amount of nitrogen. Right, so let's recap. This is how much nitrogen that I have formed. So step 1, I balanced. So I got this ratio here. But what was my actual ratio that we're looking for? We're comparing nitrogen is to ammonia. Nitrogen is to ammonia. So for every 1 nitrogen, I have this. For every 2 moles of ammonia, I have this over here. Then I needed to calculate my molar mass over here. So this calculation should have been here as well. Right, so I've got my 28 and I've got my 17. But I know, what do they give me? They only give me 98 grams of ammonia. They give me 98 grams of ammonia. It is my responsibility to find out how much of this I have. So I'm going to say 98 divided by 17. So I've got 5.76 moles of it. Right, that's how many moles I have. But that's not really how many moles, because that's how many moles I have in total. But remember, my ratio is 2. 2 is to 1. So I still need to divide it by 2 over here. Divided by 2, why? So I can get my 1 over there. That 1 then 4 means I get 2.88 moles. This 2.88 moles, I'm going to multiply it by 28. Why? Because this 28 is my molar mass for nitrogen. Right? There you go, molar mass for nitrogen. So 2.88 times 28 is going to give you 80.64 grams. Right, that is your stoichiometric calculations. Now, for some of you, this was a bit complicated in terms of my ratio. Now, there's another way that you can do it. There's multiple ways that you can do stoichiometric calculations. Now, based off all of this over here, I'm going to show you another method. I have this ratio here, and I was looking at 1 is to 2, which means now I'm going to actually just calculate the molar mass. Right? The molar mass for that over there, it's going to be my M for nitrogen, which is going to be what? 2 times 14, which we've already seen. So it is going to be 28 over here. And then I'm going to do the same thing for this one here. I know it says supposed to be Gmol, but in this instance, I'm not going to do that, just so that I can show you what is happening over here. But this one, I've got 2. So it's going to be my mass, 2 times all of this over here, which is going to be 14 plus 3 times 1, right? 14 plus 3 times 1 over there. So it's going to be my mass is 2 times 17, which is going to be my mass is equal to 34 grams. Okay, now what I've done differently, I've included this over here. Now, this is the other option. If you don't want to learn this option, then you don't have to. I do believe that this is a lot easier than the other one, but pretty much all I've done is include the moles over here. Right, so now that I've got that, all I need to do is now calculate, once again, my number of moles. Right, so I'm going to say now, they had told us 98 grams of ammonia. This is ammonia, so I'm going to say now N is equal to 98 over here 34, which is going to then give us 2.88 moles, which essentially lets us skip this step here. Right? So there's 288 moles over here. Now I know how much it has decreased by. With this 2.88, I can then straight away just say, what was my ratio? It is going to be over here, 28 times 2.88, which is going to give us an answer of 80.64 grams. So if you'd like to think of it like this, this is the same as me saying 28 is to 34 grams in terms of my ratio. For every 34 grams, I produce 28 grams of nitrogen. It's nice to know both ways, just so how everything is working. Right, this is a shortened version of everything, what's happening in terms of stoichiometric calculations. You can choose which one you would like to do. Hopefully it is, well, I don't know if this has been showing the whole time. Well, hopefully it's been shown the whole time and everything is there. Thank you very much and enjoy the rest of your day.